It began with a silence no one expected. On a quiet September night in 2025, the world's most powerful telescopes suddenly went dark. Screens that usually glowed with the light of distant stars turned black, and for 36 long hours, the sky itself seemed to disappear. Scientists called it a scheduled maintenance period, but some couldn't shake the feeling that something else was happening. Because at that exact moment, a strange object from beyond our solar system was passing close to the Sun. It wasn't just another comet. It was 3I Atlas, a traveler from another star, glowing faintly in the dark while the world looked away. Somewhere on Earth, a few small observatories still recorded its light, unaware that they were capturing the only evidence of its passage. What secret was hidden in those missing hours, and why did only one nation keep its eyes open? It started in early July 2025, when a telescope array in Chile picked up a tiny moving speck of light against the darkness of space. At first, analysts thought it was just another comet, one of many that pass by our solar system every year. But when scientists ran the orbital calculations, something didn't fit. The object wasn't following a normal path around the Sun, it was escaping it. Its trajectory was open and hyperbolic, a shape that meant it was not bound to our solar system at all. That single clue changed everything. Astronomers realized they were watching something from another star. The object was soon named 3I Atlas, the third interstellar visitor ever recorded, after Oumuamua in 2017 and Borisov in 2019. What made this one different was its timing. It appeared just as global observatories were preparing for maintenance and equipment upgrades. Still, data kept coming in. The strange traveler was moving at more than 130,000 miles per hour, glowing faintly with a greenish haze. But when its spectrum was analyzed, scientists found something that made them pause. There was almost no sign of water. Instead, it was made mostly of carbon dioxide. How could something so dry shine so bright? It happened without warning. In the final week of September 2025, as 3I Atlas moved closer to the Sun, observatories across the world prepared for routine maintenance. No one thought it would matter. The schedules were planned months ahead, and each telescope had its own reason to pause. But when the moment came, all of them stopped at once. At NASA's control centers, the live feeds from Hubble froze. The James Webb Space Telescope entered a cooling cycle as engineers switched its instruments. In Chile, the Very Large Telescope began mirror cleaning, and both Gemini North and South turned their focus to planetary studies. For a short time, it looked like a simple coincidence, just overlapping procedures. Yet those hours would soon become the most mysterious gap in modern astronomy. For 36 hours, the world's biggest eyes turned away from the sky. During that same window, 3I Atlas passed through its closest point to the Sun, a position called perihelion. The timing could not have been worse. It was when the comet would reveal its most important secrets, its structure, its surface, and the gases it released as heat struck its core. But Earth's greatest telescopes were silent. The data feed stopped, and a blank line appeared in the global light curve. To the public, nothing seemed wrong. To astronomers, it was a disaster. When they returned online, the object had already moved more than 620,000 miles along its path. The missing observations could never be replaced. A once-in-a-lifetime opportunity had slipped through their fingers, and no one could explain why every system paused at exactly the same time. Some blamed bureaucracy, others technical failure. A few whispered about something more deliberate. Could it be that someone wanted the world to miss what happened near the sun? Inside research teams, arguments grew tense. The blackout had left too many unanswered questions. Was there a sudden flare? Did the object release new material? Did it change its speed or direction? Without direct images, scientists were left guessing. And as weeks passed, a strange pattern began to emerge. All Western observatories had been offline, but one group had not stopped watching. High in the mountains of Tibet, Qinghai, and Yunnan, China's automated telescopes kept their lenses open. The air there was thin and dry, perfect for optical tracking. Their smaller mirrors captured light that no one else saw. While the world slept, their instruments recorded the silent passage of an interstellar traveler. Every few seconds, the sensors took short exposures, carefully time-stamped by GPS and transmitted through frozen fiber cables to secure data centers. Engineers in Beijing and Nanjing monitored them through the night, their servers humming in sub-zero temperatures. The teams didn't realize it yet, but their data would become the key to solving the mystery. When global systems reconnected, Chinese scientists released a quiet statement confirming continuous observation of 3I Atlas during the international gap. At first, few noticed, but when Western analysts reviewed the timestamps, they realized something extraordinary. These were the only full records of the object during its brightest moment. The news spread quickly. It wasn't the most powerful telescopes that captured history, but the ones that refused to blink. For decades, astronomical truth had flowed from the same places: Hawaii, Chile, and the Canary Islands. Now, the balance has shifted east. While half the planet went dark, the other half watched. What exactly did those smaller observatories see during the blackout? And why did the world's most advanced instruments fall silent at the same time? The answer, as scientists would soon learn, was hidden in the light itself. While the world's largest observatories shut down, a handful of smaller stations high above the clouds kept watching. In the thin air of Tibet, Qinghai, and Yunnan, the night sky is sharper than almost anywhere on Earth. Here, surrounded by snow and silence, a network of Chinese telescopes kept their lenses open when everyone else turned theirs away. These observatories were not the biggest or the most powerful, but they had something the others lacked: time. They never stopped tracking. Each telescope operated on an automated schedule, guided by algorithms that adjusted to changing weather and angles. Every few seconds, they captured a short exposure, locking onto the faint glow of 3I Atlas as it raced past the sun. Their data was transmitted through freezing fiber optic cables to secure servers in Nanjing and Beijing, where engineers monitored them through the night. The team called their system "servers under ice" because the machines ran in underground facilities kept at sub-zero temperatures to prevent overheating. What they recorded during those 36 hours would later shock the scientific world. The comet's brightness increased by about 1/3 of a magnitude. Its coma, the glowing cloud of gas and dust surrounding it, stretched toward the sun, not away from it. This was the opposite of what should have happened. Normally, solar wind pushes a comet's tail away from the sun, but 3I Atlas defied that rule. Something inside it was pushing back. When scientists analyzed the images frame by frame, they noticed that the light wasn't uniform. It pulsed in faint, rhythmic patterns, as if the object itself was breathing. Some described it as a heartbeat of light, repeating every few minutes. The brightness curve formed gentle waves, too consistent to be random. At first, the data was met with skepticism. Many experts thought it was an optical illusion caused by the thin atmosphere or the movement of the telescopes themselves. But when the Chinese teams compared data across 3 separate observatories, the pattern held. The pulse was real, synchronized across all instruments. More surprising was the spectrum of the light. Instead of the usual blue and white hues caused by water vapor, the readings showed greenish emissions from carbon dioxide and traces of carbon dust. It was as if the comet was made of frozen air, not ice. The size of the particles ejected from its surface was much larger than anything seen before, some more than a millimeter wide, dense and metallic looking. This strange composition meant one thing. 3I Atlas had not formed in a place like our solar system. It was born in a colder, darker region of space, perhaps orbiting a red dwarf or a dying star. Its presence here was like a postcard from another world. As the Chinese data circulated, the reaction from Western astronomers was mixed. Some praised the precision of the observations. Others hesitated to accept them until they could be verified independently. But one fact could not be ignored. Without those 36 hours of data, the story of 3I Atlas would have been incomplete. The world's understanding of its true nature now depended entirely on the eyes that never closed. For the first time, the flow of cosmic information had shifted. The frontier of discovery no longer belonged to the biggest mirrors, but to those willing to stay awake when others rested. What exactly caused that reverse tail and the rhythmic glow? Was it a natural reaction to sunlight or something we still can't explain? The next discovery would make the mystery even deeper. When the blackout finally ended, the world expected confusion. Instead, what arrived was something far stranger. The data collected from China's mountain observatories began to circulate through private science networks. At first, it seemed routine sets of brightness curves, exposure timestamps, and spectral charts. But the more experts examined them, the more impossible they appeared. The images showed that during the 36-hour blackout, 3I Atlas had changed. Its coma had expanded in the wrong direction, its color had deepened, and its structure seemed to pulse in ways no natural comet ever had. Scientists tried to dismiss the findings as calibration errors, but the data was too precise. Each exposure was verified against atomic clock records accurate to a millisecond. The images matched across 3 observatories thousands of miles apart. There was no sign of distortion, no trace of noise, and no overlap with any known software artifact. What they had seen was real, and it broke every rule of cometary physics. Normally, a comet grows brighter because sunlight turns its ice into vapor, but 3I Atlas barely contained any water at all. Instead, it emitted carbon dioxide frozen gas that requires far lower temperatures to exist. Even more bizarre, the outflow seemed directional, as if the object was controlling where the gas escaped. Some frames even captured a faint spiral jet, a narrow stream of dust curling around its axis like smoke from a slow-turning wheel. The pulse pattern recorded in the brightness data appeared again in the spectrograms. Every few minutes, the light flickered at almost perfect intervals. Some physicists compared it to mechanical rotation, others to a timing system responding to heat from the sun. But the rhythm was too precise to be random. The object was behaving like something that knew what it was doing. A group at the Chinese Academy of Sciences ran a simulation to test one theory. They modeled a hollow object with vents that opened and closed as it rotated. The results matched the observed data almost perfectly. If correct, that would mean 3I Atlas was not solid at all. It was partially hollow, with internal chambers releasing pressurized gas, a structure that behaved more like a machine than a rock. When Western scientists reviewed the findings, skepticism turned into unease. At Harvard, a small task force led by astrophysicist Dr. Laura Henson analyzed the spectral lines again. She confirmed that the emissions contain traces of metallic carbon compounds, something that doesn't occur naturally in comets. They resemble materials used in advanced heat-resistant alloys on Earth. Her team's report ended with a single chilling line: if the data holds, 3I Atlas may not be purely natural in origin. The claim spread quietly but quickly. Some dismissed it as a translation error or a misinterpretation of the chemical data. Others whispered that it might explain why the blackout happened in the first place. If the world's largest observatories had been online, perhaps they would have seen something governments didn't want revealed. Meanwhile, Chinese scientists continued their work, cautious but intrigued. They compared the object's rotation speed, gas velocity, and trajectory. Every measurement confirmed the same unsettling truth. The jets were too balanced to be random, the axis too steady, the pulses too clean. It was as if 3I Atlas had a system of control. When all the results were finally presented, the report's opening sentence captured the world's attention. Nothing about the object has changed, and yet everything has. It was not just a scientific observation. It was a warning that our understanding of what drifts through the void might no longer fit within the laws we thought we knew. If 3I Atlas truly possessed structure, rhythm, and control, then one question remained: who or what had built it? The moment China's report reached the international community, silence followed. At first, it wasn't denial, it was hesitation. No one wanted to say it out loud, but the implications were clear. If 3I Atlas truly behaved as the data suggested, then something outside human understanding had just crossed our solar system. The problem was not the discovery itself, but who had discovered it. For decades, astronomical authority had rested in the West. From the Hubble Space Telescope to observatories in Chile and Hawaii, science had been guided by familiar hands. Now, the clearest data came from mountain stations in China. Within days, news outlets began to question why NASA and ESA had released no official comment. Reporters asked whether Western telescopes had seen the same thing during the blackout. Spokespersons responded carefully, calling the data under review. But behind the scenes, the mood was tense. Private emails between institutions showed confusion over how to handle a discovery that could reshape not only science, but global influence. At Harvard, Dr. Henson's team requested access to China's raw image files. The request was acknowledged but delayed, citing national data policies. European researchers sent their own inquiries and received the same reply. The hesitation was mutual. China, proud of its role in saving the global timeline of observation, was reluctant to share the full data set. The result was an invisible standoff, a scientific Cold War fought in silence. Meanwhile, online forums and independent researchers began piecing together fragments of the puzzle. Some argued that the blackout had not been accidental at all. They claimed it was coordinated, a joint decision to prevent panic before governments understood what was really out there. The theory gained traction after a leaked memo from an unnamed European agency suggested sensitive findings had been removed from public archives. NASA's official channels remained quiet. The James Webb Space Telescope continued its mission without a single mention of 3I Atlas. Even when journalists pressed for answers, the agency avoided specifics, repeating that the object had already left the inner solar system. To many, it sounded less like an explanation and more like an escape. But science could not be contained by politics forever. Independent analysts confirmed the Chinese data using archived radio readings from minor observatories in Japan and Australia. The signals matched perfectly. That meant China's instruments had been right all along. 3I Atlas really had emitted patterned light with a directed jet and an unnatural composition. As the evidence grew undeniable, Western media shifted tone. Articles began describing the discovery as a triumph of global collaboration, even though no collaboration had existed. The narrative changed from competition to unity, an attempt to smooth over the uneasy truth that the world's most powerful telescopes had blinked while others kept watching. Inside government circles, questions grew deeper. What if the object wasn't just a comet, but a probe? What if someone or something had designed it to test our response? Officials debated in private while pretending to be calm in public. The issue was no longer scientific. It had become political theater on a cosmic stage. For the first time, astronomy revealed more about Earth than about the stars. It showed a species still divided, racing to own the truth rather than understand it. The comet had come and gone, but its shadow remained, stretching across borders and ideologies. And as the light of 3I Atlas faded into the dark, one question hung over the entire planet. If the universe had finally spoken, which side of Earth had truly listened? As weeks passed, the storm of politics and speculation began to quiet, leaving only the data cold, measured, and impossible to ignore. The combined analysis from observatories across the world finally confirmed what many already suspected. 3I Atlas was not bound to the Sun. Its path was hyperbolic, ensuring it would visit our system only once before vanishing into interstellar space. Its core was composed mostly of carbon dioxide and complex carbon dust, with almost no water. It reflected sunlight differently than any known comet, scattering greenish light like frozen air. Everything about it pointed to a distant alien birthplace. But beyond the numbers, something deeper emerged. The phrase in China's final report, "Nothing about the object has changed," and yet everything has begun to take on a meaning beyond science. The object itself was silent and constant, but what it revealed about humanity was not. It showed how fragile our systems of knowledge truly were, how a single blackout could divide the planet between those who saw and those who didn't. Scientists tried to focus on the technical side. They measured its light curve again, calculated its escape velocity, and estimated its composition using advanced models. Yet for many, the mystery had shifted from physical to philosophical. Why did this visitor arrive precisely when human observation faltered? Why did it appear at the moment the world's instruments went blind? Some saw coincidence, others sensed design. Dr. Henson at Harvard called it a cosmic mirror. She explained that every interstellar object reflects not only light, but also our state of awareness. When 3I Atlas appeared, she said, it didn't just travel through our solar system, it passed through our perception of control. Her words spread across social media, quoted in thousands of posts and news segments. The object had become more than a comet, it had become a question. Meanwhile, deeper analyses of the data revealed something stranger. The brightness pulses that had puzzled scientists earlier now seemed to follow a mathematical rhythm almost like a pattern. When plotted, the intervals formed ratios close to the Fibonacci sequence, a natural order found in shells, galaxies, and DNA. For some, it was an eerie coincidence. For others, it was the first whisper of intention. Could this rhythm be a signal rather than a side effect? The idea sparked debates worldwide. Some dismissed it as confirmation bias, an attempt to find meaning where none existed. Others argued that if life elsewhere followed mathematical laws, then a repeating ratio could be its most universal form of communication. After all, light is the one language that transcends distance. As 3I Atlas moved farther from the Sun, its glow weakened. Telescopes could barely trace its fading tail, yet the discussion it left behind grew louder. Scholars, philosophers, and ordinary people all wondered the same thing. What if it wasn't here to be found, but to test whether we were watching? NASA's official statement eventually called the event a valuable opportunity for international cooperation. But between the lines, many read something different. A quiet admission that we still don't know what truly passed by. When the object finally disappeared into the dark beyond Mars, it left behind no signal, no debris, only silence. And in that silence, the world heard something unexpected, a reflection of itself. If the universe truly speaks in patterns and pauses, maybe this was not just a comet's journey, but an invitation. An invitation to keep looking, even when the sky seems quiet. As 3I Atlas drifted away into the darkness, the world was left with more questions than answers. No explosion, no signal, no trace, only silence. But that silence carried weight. It forced humanity to confront something we rarely admit, that we are still listening for meaning in a universe that speaks in whispers. For 36 hours, half the planet went blind, while the other half refused to look away. That contrast became the story's most powerful symbol, not of division, but of discovery. 3I Atlas reminded us that truth does not belong to nations or agencies. It belongs to those who keep watching when the rest of the world turns away. In its quiet journey, it revealed how fragile knowledge can be and how easily light can vanish when pride overshadows curiosity. It showed that the next great discovery may not come from power or prestige, but from persistence. Even now, scientists continue to analyze its faint data trails, hoping for one more clue hidden in the light. Some say it was just another comet. Others believe it was a message, a test of whether humanity is ready to see what lies beyond its comfort. Perhaps the truth is somewhere in between, waiting for the next visitor to pass by. Because maybe the universe doesn't shout. Maybe it teaches through silence, through the moments when we choose to look up instead of away. If 3I Atlas was the universe's way of reaching out, then the real question is not what it was made of, but whether we were truly paying attention when it passed.